Once again, good morning, and you are welcome to another beautiful Friday morning lecture. It's good to have you. And today we are going to focus on a very simple, uh, well, also a very important aspect of the PGM, which we will continue to uh, encounter in the throughout the rest of the course. Uh, as you will know, this this chapter 2 focus extensively on probability, and deliberately have you know uh, taking time to make sure we have a very strong understanding and appreciation of those probability concepts. In the previous lectures, we've talked about uh, those basic probability concepts, which are put together as fundamentals of probability theory. Uh, we've looked at the probability, we've looked at random variables, how they are defined, and how they are used, particularly to construct the probability distributions. We've looked at the properties or the rules of probability. We've also considered uh, other related topics like joint, marginal, conditional probabilities, and most importantly, distinguish between independence and conditional variables. And we've discussed the Bayes theorem and how to make sense of it. We've also looked at the applications with examples. So you have all of that in the video for the previous lectures. So if everything is fine to this point, today the agenda is to focus on this particular section, conditional probability tables, CPT. In PGM, particularly in the Bayesian networks, we've, we've seen that you you have variables at the nodes, and the edges show the flow of influence, the direction of influence. I believe you can still recall clearly. So when you have the nodes and you have the arrows showing the direction of the flow, that's Bayesian network. So we talk of this as the parent. We are still going. So so this is A is the parent of B, but remember A is a variable. So um, so A is a variable, and well, the variable could be discrete or continuous. Um, if it's discrete, yes, Udo, or is it an error?
No, I think because you're not sharing your screen yet, sir.
Oh, I'm not showing my screen.
Yes, sir.
Ah, sorry. I thought I started sharing. And nobody called my attention to that. Sorry, sorry. Okay. Maybe I have to quickly, yeah. So I don't know why you feel shy. You should always unmute and call my attention anytime uh, something is amiss. Uh, Let me quickly recap uh, what I've said. I actually run down through this chapter 2, and I said that in this chapter 2, if you recall, we focus on the fundamentals of probability, and it's there that we talk about uh, basic concepts like random variables and how they are used to construct probability distributions. And we even look at probability distribution tables, joint, marginal, conditional, no, and we look at uh, independence, the difference between or when two variables are independent and when they are conditionally independent. Uh, we also talk about and took a few applications uh, and examples in linguistics of probabilistic models. So we are now looking at uh, one major uh, uh, aspect, which I said will continue to uh, encounter in the course of this lecture, and that is conditional probability table. And I was trying to define, um, um, build the foundation for the discussion around conditional probability tables. And that took us to this uh, representation where I said that in Bayesian networks, you have this type of representation. You have variable A, variable B in the nodes, and then you have the edge, which is showing the arrow showing the direction of influence. And I said A is the parent and B is the child. But most importantly, the A there is always a variable. We've defined the concept of variable. So anything that takes different values is what we regard as variable. And we've done, so we've taken several examples in the past. One of them is when you consider emails and you categorize them, so either as spam or not. That is discrete. So it's either spam or not spam. That is discrete. It, it has only two levels. Gender, again, is discrete. It has only two categories. So if the variable is taken is in categories, then we say it is discrete. And if the variable is measured, then we say it's continuous. Age is a variable, so it's measured on a continuous scale. Weight, height, no. Number of pages in documents, those are measured. But discrete are usually in categories. So that's how you distinguish. But our focus will be for now situation where variables are discrete. So A could be level of yes or no. B also could be level of yes or no. So, which means looking at the flow of this arrow, what will happen to B, whether if B yes is conditioned on what happened first to A. If B will be no, it's also conditioned on what happens to A. So you could possibly have a table which will show A, which could be yes or no. You also have B, which could be yes or no. So you could have a table like this. So which is going to give us what we now call the conditional probability table. And this table will show the probability of B equals to yes. I mean this place, given that A is also yes. That's what will be here. So that's why we call it conditional probability. Cassava, what will be the probability that I will write here?
So that would be probability of B equal to no, given that A equal to yes, A equal to yes.
Excellent. Please, let's clap for him. Cassava is the only brilliant person today. So, who is going to tell me the probability that will be here? Olusegun. Eddie Diong. Damola.
Sir, I can't
Yes.
see the place. I can't see
Here.
the cell. The cell
This
you are referring to.
this cell, this cell, this cell. You don't see
Okay,
the cell, Amma.
I've seen it.
Okay.
Probably that A equal to no, given that B is equal to yes.
Think very well.
Okay, I'm sorry, B is equal to yes, given that A is equal to no.
Yes. Please, let's clap for him. So that is probability of B is yes, given what? A is
That
no.
A is equal to no.
Yes. I'm back. Ganiyat, are you there?
Yes, sir.
Okay. Would you like to uh, talk about this one?
It will be no, sir.
Eh? Eh? Eh?
I said it will be no, sir.
You've not been following this discussion, Ganiyat. Okay. Uh, you've not been following. Eddie Diong. I'm coming back to cassava so that it will be. Cassava, are you there?
Yes, sir.
Okay. You know where I'm.
So
Yeah, go on.
that would be probability of B equal to no given A equal to no.
Excellent. Let's clap for him again. Probability of B equals no, given that A is no. Sorry. So this table now, when we supply those values, we now call this table the conditional probability table. I want you to have very solid understanding of this because it will. Yes, Chief Udo. Udo, okay.
Yes, sir. Good morning, sir.
Good morning, sir.
Okay. I'm following. I just understood the last one. I was able to get that one correctly. But when we started afresh, when we started newly, I did not get the first, second, and the third one correctly. So I don't know if you could help me go through it again just once.
You will need to watch the video at your own. Already, we have a lot of things to do today. And of course, there will still be more examples because I want everybody. And once I'm through now, Honey and Kafayat will still uh, uh, engage you with more practical example. But I always encourage you to flow, always flow with the lecture from the beginning so that you don't take us back. If I go back now, that will take our time. So if your problem is so serious, type yes in the chat menu. Only Ghanaian will type yes, I know. Nobody has typed, so there are no serious problems. Now let's look at this particular example. Look at this example. Always because of the nature of the class. So we are going to look at two examples, one in the area of environment and nature, and then the other one will be connected to linguistics, so that our friends in linguistics will have a better appreciation too. So I've already explained, when we talk about conditional probability table, it's nothing but it's a table that shows how likely an event is to happen given that another event has already occurred. And that's precisely what I'm trying to show here. We are looking at the likelihood of B occurring given that A occurred. And I mean, we usually put it as probability of given A. So that expression is conditional probability. And the table that now shows all possible levels is what we call the conditional probability table. So the table shows how likely an event is to happen, given that another event has already occurred. So instead of just asking, for example, if we are looking at rain and the we are looking at the cloud and the possibility of rain. So let's say you have we are looking at cloud, we are looking at rain. So cloud could be cloudy. So if it's cloudy, we say yes. So we are creating a variable around cloud now. If it's not cloudy, we say no. So cloud is taking two levels, yes or no. Rain is another variable this time around, which could also be rain, which could also be yes or no. So we could have a sort of hypothesized situation to say, okay, which one is the parent? Which one is going to influence the other? So who is going to tell me? Obviously, you know that the rain. Yeah, who is telling me?
Okay, so I want to try.
Try. It's good to try. No.
Mm. I'll say that the rain is the parents while cloud is the child, because
You mean
rain
yes, go on.
because rain influences the cloud. Whenever we see cloud, we know that rain is somewhere. So
Really?
Um,
Really?
yes,
Really?
I
Really?
believe so.
Udo. If the cloud is, I think the reverse is the case, Udo. Um, if you go out and you see the cloud forming, uh, you have what's that telling you about the likelihood of rain? After rain, the space is cleared. Don't you think so, Udo?
Okay, I think it's correct, but somehow I
Yeah.
believe that the cloud is as a result of the influence of rain, because I see
Okay.
rain to be,
Don't,
I see
don't,
it to be okay. I'm listening.
don't let us debate this because of time. But the uh, possible direction will be that uh, the cloud formation will produce the rain, right? So whether it will rain or not will depend on whether uh, the cloud is formed or not. So that's what we are trying to. That's what we are trying to do here precisely. So, in other words, we uh, we are simply, interested now in having a table, a conditional probability table. Why? Because we want to be able to answer questions such as how likely, you know, uh, or what is the chance of rain if it's cloudy today. So you observe the cloud and then predict the likelihood of uh, having rain. As so that's the kind of question we want to be. The CPT helps us to answer. So in general, CPT, that's conditional probability table, helps us to answer the question like how likely is it that an event will happen given that another event has already occurred? How likely is it that an event of rain, for instance, will happen given that it's cloudy? So I can, if I have information about the state of cloud, uh, then I'll be able to predict the likelihood of having rain. So that is what the conditional probability table, helps us to achieve. So we could possibly have a table uh, like this, so that we have rain here, which could be yes or no, and we have rain here, which could also be yes or no.
The other one is cloud, sir.
Oh, sorry, thank you.
Cloud. The other one is cloud.
Yes, which one is cloud? This one, right? So this one is cloud.
The one on the
Thank you very
left hand
much.
side.
That means you are following the, so this is cloud. So if it's cloudy today, then we say yes. So, so this table now gives us the likelihood of, so the probability, of course, whatever value we have now here will give us the conditional probability of having rain, given that the weather is cloudy today. So, and so on. And so on. So the values are now in the table here. And I want us to see how it is now discussed. So you have 0.7, which could be translated as saying if it's cloudy, then in other words, here it is yes. Let me put it there so that you can be able to flow. This is 0.7. This is 0.3. This is 0.2. This is 0.8. So, by interpretation, that 0.7 is simply saying that if it's cloudy, there is a 70% chance of rain. And this 0.3 is saying if it's cloudy, there is 30% chance that there will be no rain. So who is going to tell me what this one stands for? Yes, Mustafa. Mustafa, you have unmute yourself.
Yes, sir. Good morning, sir. So it is telling us that it is not cloudy. The chance that it is going to rain is so slim.
So what you have to be, the value is already given. So you have to be quantitative. You have to be precise. That's what probability measures, rather than using the word the chance is high, the chance is low. But probability helps you to quantify that chance. And that's what takes you away from the linguistic, ordinary language environment to a probabilistic, more precise. Yes, can you reconstruct your response now?
Okay, sir. If the cloud is if it is not, if the sky is not cloudy,
yes,
it is not going to rain.
There is not that it's not going to rain. Only you are still okay. It's not that it's not going to rain. Only that the chance is 20%.
It is low.
It is low, which means you are not. When I've told you before, when you say it's not possible, then you are in fact saying the probability is 0. So when you say it's not possible, It's not, you are already saying the probability is 0. So, but the measurement here is 0.2, which is very clear. So I always want you to be to know how to draw your conclusions without being unnecessarily verbose, or you have to leave your linguistic stuff to now become truly computational, and you are now able to quantify whatever statement you are making. Who is going to help us with this? Yes, Oyelaya.
Good morning, sir.
Good morning.
So for the last one, if there is no cloud, there is 80% chances that there will be no rain.
So excellent. So if we observe the cloud and it's not cloudy, then the chance that there will be no rain is 80%. That's the way I want you to understand it. So you should know that the probability value lies between 0 and 1. When it is 1, then it is certain. It means there is no doubt it will happen. When it is 0, it's not possible. It's an impossible event. But when, in most situations in life, the chance may be close to 1, which gives you greater hope of that event happening. And when it's close to 0, like this one, it's giving you less hope of the event happening. So, but that measurement itself is very important. That value must be interpreted and must be stated. Is that clear? So this is the kind of thing we'll be facing, and that's why we need to understand it, going forward. I have another example, and I think I shared this document on the WhatsApp group. Did you see it?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, I think it should be very clear to you now. Then the other one is around is on linguistic problem rather. So again, this is a very interesting example or application of the CPT in linguistics. We can examine how the ending of a word affects the likelihood of it being a noun or verb. I think those in linguistics will know that. Can anybody from linguistics say something about this? How the ending of a word affects whether that word will be a noun or a verb? Nobody in linguistics, so that we understand that this thing is possible. Yes.
Sir.
Who is talking? Okay, Mustafa. I'm coming, Cassava. Mustafa, go on. Mustafa, unmute yourself.
Yes, sir. I only want to try, sir. So it is
Okay.
telling us that if the word is ending with ing,
Yes.
the probability that it is going to be a
No,
noun
no,
is 30%.
don't talk about probability yet. I want you to give me words that will change depending on whether we had the word no. No, sorry. Give me words that change, either from noun to verb or verb to noun. By what happens, by what we do to end the word. Cassava, I think you have idea.
Yes, sir. I will also try, sir.
Okay.
Sir, I believe what I can say about this is that there are some words that they can function as verb, and then normally when we add ing to a verb to words, in most cases it is a verb, but in some cases those verb can function as noun, as in case of gerund.
As in case of
Gerund, sir. We call them gerund. Those are verbs that ends with ing, but they function as noun.
okay. Okay, let's take simple example. If I write build, and I also have a building, what's the part of speech for build?
Build is verb, sir.
A building.
That's a noun.
So what do you notice? By simply adding
Ing, sir.
ing, that changed the part of speech, isn't it?
Yes, sir.
Uh-huh. So
Sorry, sir. I have an observation, sir.
okay.
I I I believe that what changes the word class is actually the article that comes before it, because if I have a sentence like I'm building a house, that building there will not function as a noun. So what really makes it what makes it a noun is that article that comes before it. That's actually my observation. I don't know if I'm wrong.
It's a good I'm not an expert like you, but I'm looking for example that will really help one to predict the part of speech of a word by simply changing or adding ing to that word. Obviously, the point is if you write build and you write building, they are no longer of the same part of speech. True or false? Udo, are you not the one talking? Are they still the same part of speech?
No, they're not.
So what has happened? By adding ing to that word, it has changed the part of speech. So it could be any other part of speech, but probability will now help us to predict the likelihood that this is the part of speech that the word has changed to. Does that make sense? Do you understand the angle we are coming in? I want our linguistic people to respond so that I can be so.
Okay, sir. I really do understand the points, but there could be a little argument here because when ing is added to a verb,
Yeah.
it's normally is supposed to maintain the word class normally because ing means action in progress. That's the action is continuous.
Yes.
That's the basic form of it. But in some cases, when we have building, building is another entry in a dictionary. That means it's an independent word. It's not the same entry with it's not the same entry with build. Build is a word on its own. Building is also a word on its own.
Okay, I think it's debate. Cassava.
Sir, thank you, sir. I think for I want to suggest a simpler one that will work here, sir.
Okay.
In case we have a situation where we have the word swim and swimming, so we can
Okay.
have swimming is good.
Thank you
So
for.
in that case, swimming is a noun. Then we have he is swimming. So
Okay.
in that case, swimming is the verb.
So by adding ing to swim, that changes the part of speech, right?
Yes, but it will have to depend on the context. So.
On the context. So yes, so you learn.
Okay, sir. Just my own little knowledge, sir. I think
Yeah.
what the other guy is trying to say is the best example for this, if a word is a verb, adding ing will be whether it is a present continuous or not. It doesn't really change to me, just my own little knowledge. I don't like it doesn't really change it to a noun in some context. It just changes, okay, is it a present, is it continuous activities or it is a past um event?
Okay.
Thank you,
So
sir.
thank you very much for but the I may be struggling with your your area, but let's understand what we are trying to do. So in the uh, in the application of PGM to this discourse, the main concern is how a word's ending affects the likelihood of it being a noun or a verb. And if that is clear, how a word's ending affects, the likelihood of it being a noun or a verb. So, which means you could have, sorry, so which means you could have here word ending, word ending. And you could have here the part of speech. So word ending may be, there are different ways of ending word, but let's focus on ing. I hope that is clear. So there are ing, and so I put it in quote, and then a word may not So I may say no ing. So these are two levels of this. So if we call this one, for instance, event A or B. So if this is POS, ing, we are saying the word ending could influence how could influence the part of speech, how the part of speech will change, and the part of speech could change either noun or verb. We are just taking this as just practical examples. It could be other parts of speech. So this is a variable, part of speech is a variable, word ending is a variable, and each of these variables have two levels. And word ending has two levels. It has ing or no ing. Part of speech has two levels. We could have more, but for this demonstration, it could be no, none, or verb. So each we have to, but we also know that so the POS, if I call this one A and I call this one B, no, then I'm looking at probability of A giving B. That is, what happens to A is conditioned on what happens to B. So you have to, if you it implies that you have observed B before, you know what B is. You have observed B, you have seen B. Now you want to compute what will happen to A. That's precisely what we are trying to talk about. So that also leads us to the CPT that we are talking about. That is conditional probability table. And this is the conditional probability table for this. So here now we have 0.3, which is the conditional probability that if a word ends in ing, then there is 30% chance that the word will be noun. And if the word ends in ing, then there is 70% chance that the word is a verb. So the same thing here. If it does not end in ing, the value here is saying there is 60% chance the word is noun. And here is saying there is 40% chance that the word is a verb. So this is hypothetical conditional probability table, which is just to demonstrate how in linguistics word ending can help predict how word ending can help predict the part of speech. So So this is what I have, and then there are other exercises. I don't know how Kafayat and Honey would like to handle that. So this is what I have for you. I will now leave you with Kafayat and Honey. They already have the material they will use to practice. Yes, Mustafa.
Yes, sir. Sorry, sir. Please, I have a question, sir.
Okay.
The conditional probability table, sir. Please, sir,
Yes.
is it related to confusion matrix, sir?
No.
Okay, sir. Thank you, sir.
When we get to confusion matrix, we will talk about that. We use confusion matrix. Confusion matrix is not probability table. Is that clear?
Yes, sir.
So it's only looking at correct, predicted cases against, incorrectly predicted cases. So it's for performance, evaluation. This is predicting probability of an event occurring given the knowledge that the other event has occurred. Do I answer your question?
Yes, sir. Very well, sir.
Great. Kafayat.
Yes, sir. Money, sir.
Let me stop sharing.
Okay, sir.
Good.
All right. Good morning, everyone. Thank you, sir. I will share my screen. I will be taking some more examples together. What Prof has already elaborated. Myself and Miss Oni. So let me share my screen. Okay. Okay, please confirm you can see my screen.
Yes, I can see from my hand here.
Yeah, thank you very much. So this exercise covered more examples on conditional probability tables, just to expand your knowledge and understanding. And in total, we have 6 questions. Yeah. I will be taking 1 to 3 with you. I, Miss Bonnie, will take the rest of the exercises. So to start with number 1, I think by now we understand what conditional probability table is and how it differs from a regular probability table. Does anybody want to answer that for us in your own words and give us examples? Okay, nobody. Nobody wants to answer it for us. That's fine. So I'll just go ahead and answer it for you guys.
Sorry, what was the question again? I'm sorry.
Okay, can you see my screen?
Yes, yes.
We are on exercise 1 now. What is conditional probability table? And how does it differ from a regular probability table? Describe this in your own words and give us an example to back it up. Do you get that?
Yes, yes, yes.
Okay, so you want to assist us? Please go ahead.
I would say conditional probability um is it shows the probability of an event happening, given that another one has happened. While
Yes.
a regular probability just like it's just states whether an event is going to happen or not. So it has no dependence on whether an event has happened or not. So for example, for conditional probability, we can say like given that there is a cloud, it's going to rain. But for regular probability, you can say that okay, it's going to rain or it's not going to rain. So,
Yes, that's very correct. Ganiat, thank you very much. So for more emphasis on how regular probability table is different from conditional probability table, is anybody raising his hand? Okay. So, okay, Mustafa, go ahead, please.
Yes, I just want to come up with examples.
Okay, thank you.
So
Right.
she is going to use an umbrella if it rains, meaning that that is the condition. If it rains, she's going to use an umbrella. That is for conditional
Yes.
probability. Then for
Yes.
the other regular one, what is the probability that the woman is going to give birth to a baby boy? So that is just like, okay, that is just a normal probability that, okay, without one being in occurrence before the other.
Yes, that's very correct. Without depending on any conditions, without attaching any other conditions, right? That event is happening independently. The probability that the woman is going to give birth to a boy, regardless of whether she's pregnant or not, right? Just an example. So thank you very much, Ganiat and Mustafa. So that answers exercise 1 for us. Now let's move to exercise 2. You are given a partial conditional probability table based on whether a sentence contains punctuation and if the next word is a capitalized noun. There are some I think in most instances in an English sentence, when a sentence contains a punctuation mark, the next word is most likely or will most likely be a capitalized noun. But before we move to example of such sentences, the task here is to complete the missing probabilities so that each row adds up to 1. By now, you know that the rule of conditional probability tables is that the sum in a row must be equals to 1. Just like the sum of a probability must not be greater than 1 and not less than 0. Now, since in this case, capitalized now can only be yes or no in each case of punctuation presence or not. Now, let me use my pen to illustrate what we have here. Can you see my whiteboard? Please confirm that you can see my whiteboard.
Yes.
yes.
Yes, I can see from my end.
All right, thank you. So here we have punctuation present. So pardon my writing. I'm using my mouse to construct this. So we have punctuation present is either yes or no, right? Oh, okay. And then the probability that the next word is going to be a capitalized noun. That's in this case is 0.8, 0.8, and 0.2 for when the punctuation is absent. Now, the probability that the next word is not going to be a capitalized noun. N stands for nowhere. We are to complete this in this case. So in this case, we already know that the probability or the total probability in the room must sum up to 1. So automatically what this tells us is 1, this is just mathematics, right? 1 minus 0.8. So we have 0.2. And also the next one, 1 minus 0.2. This gives us what? 0.8. That's for this one, this means that probability that the capitalized noun is next to when there's a punctuation mark, or to simply put it, let me write this in probability times. Next one is probability that. This simply means that probability that capitalized, this in your own case, make sure you always write in full. I'm shortening it because I'm not using the touch to write this board. So to write in full is we kind of disorganize the board. So probability that capitalized now is next given punctuation is present is also yes. In this case, according to the table, who can tell us what this is? That's 0.8, right? Please, if you not get what I'm trying to do, feel free to interrupt at any point in time. Just unmute and then ask questions. So the next one here means, let me go to this. This is telling us that probability that the capitalized noun is not next as no, right? Given punctuation marks is absent. That's 0.2, right? And for this, who is going to tell us what this is going to be in probability terms? Okay, go ahead, please. That's okay, Mustafa. Please go ahead.
No, sorry, your white screen. Okay. So it is telling us that the probability that punctuation is present is close to non-capitalized. That's CN. Sorry, I don't understand the other abbreviation.
You mean the one I wrote, right? You see, the
Yes,
first
the second one.
okay, our probability, conditional probability table here. Here we have in the first row, we have punctuation, the probability that punctuation is present, and then the capitalized now is next. Let's go back to the question for you to understand this better. He said you are given a partial CPT based on whether a sentence contains punctuation. That's the P there. And if the next word is capitalized, right? Now, based on this table now, this is simply telling us that the probability that a capitalized noun is the next word, given that there is a punctuation present, that is this 0.8. Probability that a capitalized noun is next, that is the next word is a capitalized noun, given that the punctuation mark present precedes than now. Do you get that, Mustafa?
Yes, I do.
0.8. Yeah. And in this case, the probability that capitalized now is next. That's what the yes here is telling us. Given that there is no punctuation mark before that now. Is that clear?
Yes, it is clear.
Okay, so do you want to
Yes.
answer this for us? Okay.
Okay, so the probability that punctuation is present, why the other words, the capitalized, I don't know. Okay, the probability that when punctuation
Yes.
is present,
Yes.
then the capitalized.
Just okay.
Can I continue?
Yes, continue.
Okay, the probability that punctuation is present, why capitalized now is not present, is 0.2. That is 20% of it.
That's the probability that punctuation is present, right?
Yes,
That's
yes,
PES, right?
yes.
Given that what CN
Given that yes,
is what
non-capitalized now is not present.
is not present. Which
Yes.
of these values are you
Okay, I'm
talking?
referring to that 1 minus 0.8 equals to 0.2.
Okay, so are you saying given that capitalized now is not present,
Yes.
but this is present? The row you are referring to is telling us that punctuation mark is present before the capitalized now. That's this row.
Okay.
Okay. Yes, and before they capitalize now, yes. And if you look at this, Mustafa, capitalized now is absent for the column you are dealing with. You see, to simply put this in a clear terms, let's say if the next word is a capitalized now, right? Then the punctuation marks that precede it, and the punctuation mark precedes it. Let's say if for the first one here, this one simply means if, let's forget the probability for now. If CN is present, that's if capitalized now is the next word, then that tells us that then the punctuation mark is also present. That is, punctuation mark precedes that word. Now, what is the probability that this happens? Then that's the first one here. Why do I put yes? Look at this column here. They are telling us that capitalized now is actually the next word. But in this case, what about the punctuation? Is it present? Is it there? Yes, it is. That's when we have the 0.8. Now, to put this in conditional probability terms, that's when we have the probability that the capitalized now precedes, given that punctuation mark is present. That's 0.8, which is, so this statement is the same thing as this. The difference is that in this, we are writing it as a conditional probability statement, and this, we are writing it as a if-then statement. Is there any more clarification to that? Mustafa, is that
Yes,
clear
it
now?
is clear. Yes,
Yeah.
yes, it is. Thank you
So
very much. It is clear.
I want you to answer this. Give us this in conditional probability statement.
Okay. If capitalized now is not present,
Okay.
then punctuation mark is present, or punctuation is present rather.
If capitalized
Now is
is
not
not
present.
present,
Yes.
okay, then
Punctuation is
punctuation
present.
is what
Present.
is present. Very good.
Mm.
That is the if then statement. Now convert this to a conditional probability statement. That will be what?
Okay, that would be probability, given that, okay, that is P, probability,
P
then the
of,
bracket, okay,
okay.
yeah, okay, P of, okay, then punctuation is
Remember
yes,
here we are putting the
okay,
capitalized
okay,
the
yes,
capitalized now occurs based on a condition that whether the punctuation mark is present or not. Do you get that? Now the
yes, I do,
punctuation, the condition in this case will be after the given that sign. By now you know that the given that symbol is this, right?
yes.
So what happens before that condition?
So we have the not capitalized now, not present,
Yes, very good. Capitalized now, not
not present.
present. Based on the condition that, or given that
Punctuation,
quotation
punctuation
mark
is present.
is present, and that value is what?
That's 0.2.
0.2. Very good. That's very correct. So who wants to try the second one in conditional probability statement? Somebody else. Okay, who is raising up? Okay, Oyeleye. Go ahead.
So for the other part, it will be
Okay.
probability, like P into bracket, punctuation mark equals to yes.
Is it punctuation
No,
mark?
no, capitalize now. Now, sorry.
Capitalized, yes. Punctuation mark is the condition in this case. So capitalized now equals
To
what?
yes. Yes.
Which of these are you? Remember we are
I'm doing the yes, the first
this
the
one, right?
second with the first column. No, 0.2. The other part. No,
This one.
no. Yes.
I've already done this one, which is
Okay.
this.
Okay, so this one will
Now,
be equals to
yes,
no,
equals to no.
given that
Given that
punctuation present is also equals to no.
quotation present equals no, and that value is what?
0.8.
0.8. Very good. Very good. I hope by now everybody understands how to convert this to a conditional probability statement. Okay, so let me create a new slide. Right. So the next question tells us that interpret what the table is suggesting about punctuation and capitalization. I guess I shouldn't have created a new one yet. Let me see if I can bring that previous one back. But let me just write out the table again for us not to waste time. We have yes and no for punctuation. Remember, this is for punctuation present or not. And here we have capitalized now to be present and capitalized now to be absent. Value here is 0.8, 0.2, 0.80.2. Now, how do we interpret this? Remember, these values are probability values. Right? Who wants to try? Okay, who is raising hand? Mustafa. Okay, go ahead.
Okay. The first one, that is 0.8, tells us that when capitalized now, given that, okay, when capitalized now is present and
Okay.
punctuation is present too, for the two to occur at the same time, definitely the probability is giving us, the probability for the two to occur at the same time is 80%.
It's 80%. Mustafa, you try, but I will give you 5/10. You can put that interpretation more in clear terms using the probability. Then there is a probability that what? Yes, you know that the two will occur at the same time. The probability is 80%. But use if this, then the probability that this will happen is this. Do you get
Okay.
that? Just to help.
Okay. Okay. If capitalized now is present
Okay.
and punctuation is present,
Okay, let me assist you with this.
okay,
Start with the punctuation column. If, but in this case, the first row here is telling us that if someone else raising up his hand. Okay, Oyeleye and Timothy. Oyeleye, go ahead. Then Timothy will go after.
Good morning, ma'am.
Good morning.
So the interpretation is when the punctuation is present, there is an 80% chance the next word is capitalized now.
Very good. That's very good. That's the statement I've been looking for. Mustafa, do you get that?
Yes, I do.
Yes. So you are as well correct, but I will give Timothy 10/10. The best statement to use in this case is if punctuation is present, that's if punctuation is yes, right? Then there's 80% chance. Remember, 0.8 is the same thing as 80. That the next word will be a capitalized noun. Remember, the condition in this case is that whether the punctuation mark is present or not. That will determine if the next word will be a capitalized noun or not. Do you understand that? So,
Yes.
who wants to interpret the second one for us? Who will interpret this for us? Okay, is anybody raising his hand? And let me call, I'll call somebody. Adetono. Yeah, I've not heard the best since fun. Adetono, do you want to try this?
Hello, ma.
Yes, go ahead, please. Good morning.
For the 0.2,
Yes.
this shows that the probability when the punctuation is present, the capitalized now is not what's
Yes,
there
go
is a
ahead.
chance that when the punctuation is not present,
Okay.
there is 20% chance that the capitalized now is present, is not present also.
Is it this one you are treating Adetono?
Yes, 0.2, yes, yes.
Yes, the capitalized now in this case is present. So not is not present. You get the statement right, but just that this is present. Do you see that? This is yes.
The first row is yes.
Yes.
Okay, yes.
This is yes. So when the punctuation mark is absent, there is only 20% probability or chance that the next word will be a capitalized
noun.
Yes, so thank you. And
thank you, ma'am.
What does this tell us? By now, you know better in linguistics, so you know that punctuation is a strong indicator of what the next word will be, right? So if there is no
Yeah.
punctuation, it is more likely that the next word will not be a capitalized noun. And this is often the case in typical sentence. So who wants to give us an example of such sentence to back up our analysis here? You might decide to type in the chat box before we move to the next question. Okay, who is giving us an example? All right, if there's nobody, I'll give you an example. A perfect example is, let's say the meeting ended abruptly. Full stop. John packed his notes. John in this case is a capitalized noun. Here's the punctuation mark here. That's the full stop, right? So that's a perfect example of what we are talking about. Now the next question, as exercise 3, before I hand over to Ms. Connie. So you have the following observations from a data set. Like you can see word ending with ed or not. And we have the count of noun and a count of verb. Now let's, the task here is to convert this into a combinational probability table showing probability of part of speech, either noun or verb in this case, given that word ending, either ed or not ed. Now, how do we go about this? Let me try to bring this table to my whiteboard here. Pardon my abbreviations because of the pen I'm using. All right, word ending in ed or not ed. And we have the count of noun. Let me use that as cn. And also count of verb, that's cv. How many? Okay, we have 10, 40, 10, 40, 60, 40. Now, how do we? Obviously, this is not a. Who can tell us why this is not a conditional probability table? Who wants to? Who wants to try? This is not a conditional probability table. Why? Okay, Mustafa, go ahead. Mustafa,
Sorry,
okay.
I only
Yes,
want to try. I'm not sure. I
yes,
only want to try.
yes, go ahead. Go
So,
ahead.
if you should look at each of the, okay, sorry, for the first row, that is that 10 and 40 for the first row.
Okay.
Maybe because it is not giving us, it is not summing to 1. If you should add the 10 plus 40, it is
Yeah,
not giving us 1.
that's very one good reason. That's very good. That's one reason. And to another reason is that a probability must not be greater than 1, regardless of the sum. Let's not go to sum. Of course, one rule of probability that the sum must be equal to 1, but in this case, even one value must not be greater than 1. So that's another reason why this is not conditional probability theory. Oh, yeah, Timothy, you raise
Yes,
your
ma'am.
hand.
Yes, ma'am. Because the table shows that is a count, is a discrete
We can't. Thank you.
distribution. Yes.
Thank you. That's very good. And that good observation. So now let's move to how to convert this to a conditional probability table. Now to do this, we need to calculate the probability of each part of speech, that is the noun and the verb, given each word ending. That's the ed and the not ed. And how do we do this? We divide the count of each of these part of speech, the count of this, all over the total count. But first, let's look at the total here. What is the total count in this case?
Yes, ma'am.
Yes, go ahead, please.
I'm following, but I'm not sure I really do understand
Which
at
part?
this point in where we are now. The table that we just drew.
Okay, that's Chief Udo. You mean the one we are currently treating, right?
Exactly.
Okay, should I start from the beginning?
Please, if you could.
Why is this? The question says, let me go to the question. The question says, convert this into a conditional probability tables showing the probability of part of speech. That's either the noun or the verb, right? Given that the word is ending with ed or not. Now, why do they ask us to convert this to a conditional probability table? Because it is not a conditional probability table. And why? It is obvious because probably a probability value must not be greater than 1. This is already greater than 1. The sum must not be greater than 1. This is count. It's obvious. They already told us that this is a count, not probabilities. So do you get it to that stage?
Yes, I do.
So
Thank you.
in order for us to now convert this to a conditional probability tables, we need probability values, not counts, right? How do we then convert this count to probability values? It's just like saying you want to find the probability of the count, the number of nouns, given that the word is ending with ed. Probability that the number of verbs, given that the word is ending with ed. The simpler way to do this is that let's look at the total of this. It's just a ratio. What's the total of each row? That is how do I put it? Divide the count of each of these over the total count. The count of it now is 10, right? What's the total count of given the count of now, given that the word is ending with ed, is 10. The count of verb, given that the word is ending with ed, is what? 40. Now, what's the total count of this part of speech, given that the word is ending with ed? Chief Udo, are you getting it? We have 50, isn't it? Also, the count of now, given that the word is not ending with ed, is 60. The count of verb, given that the word is not ending with ed, is 40. What's the total count? That's 100, right? Now, let me bring this to another thing here. I want to convert this to a probability. By saying that to do this, we need to divide each of these counts by the total count. The first one here for ed, we have 10 over 50, right? Here we have this. Feel free to interrupt if you are not getting what I'm doing. 40 over 50. Then what do we have here? Who wants to tell us? 60 over what?
60 over 100.
Over 100. Thank you very much. Then here we also have 40
over 100.
over 100. Now, each of these values will give us 10 over 50 will give us 0.2. Right? 40 over 50 will give us 0.8. 60 over 100 will give us 0.6. While the next one will give us 0.4. Now remember, this is no more count, but we can still say now. Let's just put now verb. You can either put count of now, count of verb, but you know they are not count anymore. They are now probabilities. And here the word is ending with ed. The word is not ending with ed. So this is our conditional probability tables. Is there any question before we answer the next one? Do you get it to this point?
Yes, ma'am.
All right, thank you very much. So What we just did is we used the total per row to compute the probabilities. Isn't that what we did? What's the total per row? That's the 50 and the 100. Now we use that to compute the probabilities already. Now the next one is write interpretation for each row. That is, if a word is ending with ed or not. Who wants to help us with the interpretation? It's very simple. Who wants to try? Okay, who has not said anything in this class?
I want to try.
Okay, please go ahead. Adeton,
Yes, ma'am.
go ahead.
The probability that nouns given ends in ed
Okay.
is 20%.
Say that again.
The probability
Yeah.
that we have a proper noun that ends in ed is 20%.
Yes, you. Adeton, you really tried, but I want the statement to start with if. If goes a long way. One thing you should know that if goes a long way when it comes to interpreting probability terms. It's more clearer, and it simply shows that you know what you are saying. You
Okay.
got it right, but I want you to try again.
Okay. The probability that if the no I don't know how to use if.
Okay.
If
Remember that this table is telling us that a word is ending with ed, and the
yes,
probability that that word is a noun is this.
yes.
Likewise, the probability that that word is a verb. Now, what if the word is not ending with ed? What are the chances? Do you get that?
Okay.
So do you want to try again?
What are the chances? Okay. The probability that if please, I don't know.
Okay.
I don't know what to
If the
say.
word, right? Is that what you want to say? If the word is start with
If
this,
the,
start with the column and the row rather.
if the word ends with ed,
Yes,
there is a
exactly.
20% chance that probability is a no.
Is a noun. Thank you very much. That's very correct. Somebody is raising up his hand. I think that was Akonji. Yeah, you want to answer the next one for us, Akonji?
Yeah, good morning, ma.
Yes, go ahead. Good morning.
Okay, yeah, the next cell is
0.8.
the probability that if the word ends in ed, that there is 80% chance that is a verb.
Say that again.
That if a word ends in ed with ed, that there is
Yes.
an 80% chance that that word is a verb.
Thank you. Thank you very much. But let me assist you. Don't say the probability that if the word ends with ed, because the probability is 0.8. Well, you are correct, but to put it in a simpler terms, if the word ends with ed, then there is 80% probability, or the probability that the word is a verb is 80%. Do you get that?
Yes, ma.
Okay. So who wants to assist with the next one? Just go ahead, unmute yourself. Yes. Who is that? Please go ahead.
So, okay, so for the next rule, if a word
Yes.
does not end with ed, there
Okay.
is 60% chance that it is a noun and a 40% chance that it is a verb.
Very good. That's very good. Thank you very much, Tupa. So I think we are done with exercise 3. Yes. So I will leave for Miss Oni to take over the rest of the exercise. Thank you. Right, Miss Oni, are you there?
Yes, I'm here. Good morning, everyone. I'll be sharing my screen.
Good morning.
Good morning.
Good morning. Ms. Kapaya, can you please stop sharing? Okay. All right, so we'll quickly move to, because our time is fast spent, we'll quickly move to exercise 4. And okay, first of all, I want to believe that we've all attempted the exercise. And so I'll be expecting that if there is a part that we were confused about, I'm expecting that the explanation that Ms. Kafaya and I will be given or has given would clarify some of your confusion. All right, so exercise 4. It says, given this CPT for a part of speech tagging, and we have the table, the CPT. The first question is, what is the probability of a word being a verb if it follows to? And Mrs. Kapaya has already done a huge task in explaining how to understand and how to interpret the table. So I'm just going to be throwing the questions to us. If you would want to try out, we already have the table, you can see the table. So from the table that we can see here, what is the probability of a word being a verb if it follows to? Who wants to answer the question?
Is 90%.
Very correct, very accurate. Yes, it is 90%. Is there anyone confused about how we got 90%? Anyone? Okay, I think there are nobody. We all understand. Then the next question is, if a word does not follow to, which part of speech is more likely to be? Which, if a word does not follow to, which part of speech is it more likely to be?
Now,
Now, can you elaborate on it? How do you?
From the table, you can see that if a word does not follow to, which is the no, it has 30% chance to be a verb and 70% chance to be a noun. So noun has higher chances than verb for that kind of word. But a word that does not follow to, so that's why the answer should be now.
Okay, thank you very much. I would want us to probably pick or give me one sentence that falls into this table. Like, okay, which sentence is it that has to? Okay, let me just do this one. What I expect. For example, now, let's say I want to eat. So the word is following. So the word eat is following to and is a verb. I think that's what we are saying here. So can somebody give me a word that follows to, but is a noun? Another word that does not follow to, that is a verb. You give me that sentence and then explain. And then likewise this as well. Is anything coming to our mind?
I don't know that for a word that follows to that is a noun, something like I'm going to church.
Good. Very good. Very good. So church in this case is a noun. And I think another example is maybe we'll say something like education is the key to success. So I think success here is a noun, if I'm correct. I know it's not a verb. So, okay, can somebody else give us a word that does not follow to, but is a verb in a sentence? Anybody? It doesn't follow to. It's just a sentence, a short sentence. There's no to there, and then we can pick a verb there. Okay, I guess we are still thinking. Maybe a situation, maybe a sentence where we have like, I am dancing. Yeah, dancing is a continuous tense, but it's still a verb, and there is no to in that sentence. So because of our time, let's move to. Okay, go ahead, Adelusi. Go ahead, please.
I want to run.
You want to run. Yeah, I want to run is in it will fall under the first, that is fall under 0.9. It fall under 0.9. It follows to and is a verb. Run is a verb in that context, right? So it falls under 0.9. All right, so let's quickly move to exercise 5. It says apply conditional probability in a Bayesian context. Yeah. So suppose you want to predict whether a word is a proper noun based on whether it starts with a capital letter and appears at the beginning of a sentence. So we have two conditions there, starting with capital letter and starting, like, appearing at the beginning of a sentence. So we have the table here. We can see the table here. The first question is, what is the most likely condition under which a word is a proper noun from this table? Don't forget, the condition that was stated here is that for you to be a proper noun, you should start with capital letter and appear at the beginning of a sentence. That's the condition. So the question is, what is the most likely condition under which a word is a proper noun from this table? Anyone?
Is 0.9.
0.9. Yeah, what's the condition? You are talking about the probability. Yeah, well, can you explain why 0.9? How did you come over 0.9?
And when it is capitalized and at the starting of the sentences.
Beautiful. Yes, thank you very much.
0.9.
So the condition, what's the most likely condition? So the condition is a word being capitalized and it's starting a sentence. There's higher tendency, 90% chance that that word is a proper noun. An example is maybe Nigeria is a country in West Africa. So Nigeria here is a proper noun. Yes, I think I'm correct. Nigeria is a proper noun. Although we also have some times where our proper noun is not starting the sentence. We also have those times. Yes, even the West Africa in that sentence is a proper noun, although it's not starting the sentence. But let's assume you have something like, we bought some books at the store. Books. One, book is not starting a sentence. Two, is not, it won't even be capitalized in that sentence. So it's an indicator that it might not be a proper noun. That brings us to the second question, which I've kind of answered. In which case is it least likely? That means in which case is it least likely to be a proper noun? So somebody, I've already said it, somebody should just reiterate it.
0.1.
0.9, that means when it's not capitalized and when it's not starting a sentence. So it's an high indicator that it might not be a proper noun. Okay, then finally, yes, I think this is where we have to, it's a task that you have to design yourself, and it shouldn't be the same. Yes, because it's something you have to think of by yourself. So the question is, choose two linguistic features, suffix and POS, word position and word type. Just an example. You can have other things you want to look into. Create a 2x2 conditional probability table. You know what we mean by 2x2, where each of the conditions or each of the variables have two levels, something like this. Yeah, where we have, yeah, so this is what is expected of you in that assignment. So let's assume that I want to work with the first suggestion here, suffix and part of speech. And say I want to work with suffix of ing. Then I want to check if it's going to be a noun or a verb, just like what we've been doing. In your own assignment, I know that the assignment is even due, but if you've not done it that way, or if you are probably going through your assignment for the sake of exam, you don't have to stick to suffix and POS. You can try other methods. So assume, okay, let's assume I want to look at something that ends with maybe ing. ing. Maybe I want to look at that. Then here, maybe I want to look at, okay, if the POS is a verb, and here, let's say if the POS is a noun. Okay, I hope it's something we can follow. Okay, so we have yes here, and we have no. So this is what is expected of you to do. This is a 2 by 2 conditional probability table. Then the next question is fill in hypothetical probabilities. Hypothetical probabilities, just hypothesize it. Just think of it and just give it a probability. Then the main question now is the interpretation. So let's assume I'm giving this 0.8. Let's assume I'm giving this 0.2, 0.3, then here 0.7, 0.7. So the next thing is write 2 sentences interpreting what your conditional probability table tells us. Okay, so me looking at this, I want just 2 people to give me one sentence each of what you can pick from this table, and then we call it a day. We have 6 minutes to the end of the class. 2 persons, maybe 1 person from statistics and 1 person from linguistics department.
If a word ends in ing,
okay,
there is an 80% chance that it is in verb.
That the part of speech is a verb. Are you in statistics or in
statistics?
Statistics. So we need 1 more person from linguistics. Linguistic, are we here? Udo, Edidion, Ghanaian, Kasaba. Those are the ones I can remember. From the explanation that Ms. Kafaya has given to us when this tutorial started, I think me looking at it, you should be able to relate. Or is there something wrong? Udo? Kasaba? Are we in the class?
Okay, yes, ma'am.
Yes, okay.
So did you hear the question, Udo, Cassava, and the rest?
You can still repeat the question, ma'am.
Sorry?
Please repeat the question, ma'am, please.
Okay, so I said, looking at the table, you can see my screen. The table I have here, I just want 1 sentence of interpretation of any part of the probabilities in this table. Any part. And somebody had already explained the 0.8 part. So just pick 1 more part from this table and interpret based on what Ms. Kafaya has explained to us earlier.
Okay, based on that, I'll pick that of 0.3.
Okay, go ahead.
Okay. I believe what is there is that if a word ends in or does not end in ing,
Yes.
there's 30% chance of that particular word being a verb.
Being a verb. Okay. Okay. All right. So thank you very much. For those that were able to submit, I hope that the tutorial today gave you better clarifications of some of your confusion. So I will just employ us to keep reading, And if you do not have the manual, please get it so that it can facilitate your learning process. All right, and if there is going to be any assignment, it's going to be dropped on the Google Classroom, so do well to check it constantly. All right, do we have any questions before we call it a day? Any question? No question, okay. One more person to just test that there's no question.
And you can always go back to the YouTube videos, prof page
Yes.
to provide it.
Yes, you know that.
So I will post, before we go, I will post what we will discuss next week on the WhatsApp platform, hopefully before the end of today. So take time to also go through in advance. Maybe that will make our discussion to flow. So enjoy your weekend. Take care of yourself.
Thank you, sir.
Thank you, sir.
Thank you, sir.
So see you
Thank
next
you, sir.
Thank you, sir.